Hi, my name's Ethan Valencia. I work for Trimble. We're going to go over how to test can voltage and can resistance. First, you're going to need a multimeter. It's a good idea to have a different type of leads so you have options. Some of these connectors can be bigger or smaller, so it just makes it easier when you have needle leads to get to those smaller spaces. Second tool that I recommend is having a Deutsch tool. These come in handy. It makes it really easy to take apart connectors and put them back together. When checking can, you need to ensure your meter is set to read resistance in ohms. Your typical setup is going to be here with your leads. Today we're going to be testing a radio for can. We're going to look for resistance in ohms. We're going to check pins C and D on the connector. More often than not, that is where our can line communication is tested. So you would take your leads, stick them in C and D, and you should have 60 ohms. So here we've placed our meter leads into C and D pins. We're reading 58 ohms of resistance. Now, ideally it would be 60, but you know, parameters, give or take a few, 58 is fine. Typically, you may see a difference in the number. It may not exactly be 60, but if it's anything crazy, like plus or minus 5, then there's an issue. But if not, then I wouldn't worry about it. There's a couple different ways to check can resistance. One way to do it is at the component itself, at that harness, or you can pick a spot in the system and test. Here we have a splitter, a Terminator, and our main connection back to the main part of the harness. Here's our splitter. One goes to a rotation sensor, one goes to a GS520. So when checking resistance, you want to ensure that your system is properly terminated. One way to do that is just take your leads out and check for resistance. When checking resistance on a 4-pin connector, you're going to use the bottom two here. So go ahead and do that. So now we know that we have 60 ohms. So this checks out and it shows no issue with can. When checking can lines, you need to know where you're at in the system. So here we have a connector from a sensor, and we have a connector that goes down the length of the boom and connects everything. So you need to know where you're at in the system. If you were to check can on this plug here, you would get nothing. But here we're checking, and we can tell that we have 60 ohms, so we're in spec. This system is properly terminated, and we're good to go. So if you know that your resistance is good here, that means that the resistance all the way back is good to go as well. So that's a quick way to test your resistance and to ensure that you have proper termination. A quick way to ensure your terminator is in working order is take your meter, put it in the bottom 2 pins, and check resistance. So here we have 118.7. Like I said in previous videos, your resistance can vary 1 to 2 values. So this is good to go. If you see anything lower, like 115, then there might be an issue, and that terminator would probably need to be replaced. When checking can voltage, what you're going to do is you're going to take your black lead, put it in the ground. For all connectors that are not 4 pins, your ground is going to be the F pin. So when checking can voltage, we're looking for 2.4 to 2.7 volts for can high and can low. First, we'll check can low. So you can see we have 2.4 volts, which is in spec. Checking can high, we have about 2.7. Now that checks out. That is within parameters, and it's good to go. Here we have a radio connector. We're going to be checking CAN voltage. So to do that, we're going to take our black lead, common lead, stick it in the B pin. That is our ground for this particular connector. Then we're going to take our other lead and we're going to check CAN high, which is C. That pegs out at 2.53, so that's within spec. Then we're going to check our D pin, which is CAN low, and look at that, 2.46, so that's within spec. Typically with CAN systems, CAN voltage, you're looking to equal about 5 volts. When checking CAN voltage, you need to know what connector you're working with. Here in my hand, I have a radio connector. To test CAN voltage on this one, you stick your common lead into B, which is the ground, and then you use C and D to check voltage. But on this connector here, you can see that's not the case. We have our common lead in the B pin and our red lead in the L pin. So just be aware that these connectors can change, so it's good to know what you're dealing with.